Hey guys and girls, I hope you guys are enjoying winter break. Here's your retest review video. I'll see you on Tuesday. So we're going to walk through this table, and in doing so we're going to talk about what makes something a function or not a function, which is when there's no x value used more than once. We'll talk about function notation. We'll talk about domain and range and how to write those. So just stay with me, keep the notes, and see where it goes. So this first one, yes, it is a function. If you look at all the x values, none of them are repeated, none of them are used more than once, so it's a function. Same goes for the second, 1, 3, 5 as x values. They're all different, so it is still a function. Now if you look at this third set of points, it is not a function because you have the 2 and the 4 that are repeating, so that's no good. The x values are being used more than once. Now down here, how do I know if this is a function or not? I don't have points. I don't have a picture to use the vertical line test. So what we can do is go into Desmos, which I'll do quickly. Start graphing. And the function was negative 2x plus 10, so I'll just plug that in really quickly. Now think about the vertical line test. If you were to draw vertical lines across this graph, is it ever going to touch it more than once? No, it will not. So this is a function because it passed the vertical line test. So that's a couple ways that we can tell differences of functions or non-functions. It's all about the x values, and if you can't see points, then use the picture as the vertical line test entails. Now with function notation, you have to be aware of, are they giving you an input or are they giving you an output? If they give you an output, which they do here in the first one, you need to find all inputs that make that output happen. So negative 2 and positive 2 work. Now if they give you the input of negative 1, go find that x value of negative 1 and then find its according y value. Domain and range, as we've talked about before, if they give you a list, you can create a list. So my domain, negative 2, negative 1, 0, 1, 2. The range, just 0, 1, and 2. You don't need the repeaters. So I'll let you guys just watch. I'll stop talking a little bit more here. Same idea. Input, output, domain, range. Now, just a small note. The reason that this range is only 6 is because the only output that is there. I realized just now that there's a mistake in this function notation stuff, so we'll cross this off there, but we can still write the domain and the range. Domain is just 2 and 4. The range is 3, 5, 7, 9. We always want to list them in numerical order if we have a list for domain and for range. Okay, so if the output is given, again, what happens with the notation of an equation is you set that output equal to the equation and then solve it. If it's an input, you plug that number in for x and see where it goes. So that's what's happening here. Now domain and range, since we don't have a list of points, we're going to have to use interval notation. If you remember on the picture, the line was going on forever in every direction. It's going down, it's going up, it's going left and right. So that's why the domain and the range for a linear function is negative infinity through positive infinity. So there's page 1. Page 2. So I'm just going to quickly pull out some points that are on this line to prove the point as to why this is not a function. 3 points, they all have the x value of 2, which is no good when it comes to talking about functions. So any straight up and down vertical line is not a function. On this picture, we're going to use the vertical line test as well as the next one, and they will both pass the vertical line test because they don't hit it more than once. Same idea as before. If they give you an input, use it to plug in for x. If they give you an output, use that as a y value and go find the x's. So I drew a little line there at y value of 2 and looked for any points that touch that. Now at the x value of 0, I draw a vertical line. X values are always vertical lines, and find the y value that hits that. Now domain, the only x value used there is 2, so I only have to write 2. The range, however, goes down forever and it goes up forever. So that's why negative infinity through positive infinity is appropriate. for these ones, I'm going to erase this really quickly so you can see, domain is x values, so the lowest x value is -4. Then it goes on forever to the right, so that's why it's going up to infinity. In this one, the y value starts at +2, and then it continues upward forever, and that's why it goes to positive infinity there. Now specifically in this graph, there's no arrow, so I can box this off to give me very definitive domains and ranges. I know where it stops and starts as we look at it. So yes, it is a function. It passes the vertical line test. Looking at inputs and outputs, take a look for yourself on that. Okay, domain furthest left is -1, furthest right is 6, range is y value, so bottom to top, -2 at the lowest, 5 at the highest. 0 is used more than once as an input, so this cannot be a function in this last one. Same idea with function notation. What are they giving you? What do you need to find? You have to think thoroughly about what method to take in each case. Then domain and range, in this case we have 2 lists, so we're going to create lists for the domain and for the range. Alright, average rate of change now. You guys know this as the slope formula. y2 minus y1 over x2 minus x1. You need 2 y values, you need 2 x values to use this formula of average rate of change. So if they give you a function like they do here, they might provide x values of -1 and 3, put those into the formula already. Now the y values are going to come from the actual function. So how do we find them? Take the function, plug in the x values that they've given you, the inputs, then those produce outputs, y values. So the 4 is going to go over -1 because those match up. 3 was going in, gives you 12, so 12 goes over 3. Then that computes your average rate of change, which in this case would be 2. Okay, now if they give you a table, the same idea is going to apply. They give you x's and y's, inputs and outputs. In this case, the inputs are 3 and 11. Yes, 3 and 11, so you put them on the bottom. Find the outputs that pair with them. Use that to your advantage. Work your way through it. You find the average rate of change at this point. 0 to 5. So again, inputs are 0 and 5. Put those in the x spots of your slope formula. Then go find the outputs. 0, 254. Let's see what you end up with as your average rate of change. Okay, so difficult function notation. It's all about input versus output. If you get inputs, plug them in. So we got 3 and -10. We're going to plug them in here. Oh, made a little mistake there. And see where that goes. This ends up being 33 as an output. This ends up being -6. So given the input, we plug it in to find the output. Now in letter C, they've given us an output. If an output is given, we need to set that equal to the equation and then solve for x. Now you could have distributed first here if you wanted. I chose to divide the 3 off. Either way is fine. Alright, so here's where the funky stuff happens. What? You've got g of -2, but what about g and f, and how do they intertwine? So let's first think about, if you see g of -2, -2 is an input for g, so you need to put -2 wherever you see x. So we'll do that there. Now this little section of f of -2, you need to bring that back into the f function. So if f of x is equal to 3 parentheses x plus 8, plug in -2 there and see what you get, which would be 18. So now this number of 18 is going to be inserted for f of negative 2. It becomes 2 times 18 plus 17, which comes out to be 53. You try the last one there on your own. Now this last page, we have a graph where we're going to see some of this funky notation as well. And then you see a piecewise function off to the right to get some practice in that. So again, the graph here is f. They give you an input of 3. Go over to the x value of 3 and find its y value. So you go up to the picture, you find that is at 3 as well. The output of 0, so where is the output or y value 0? That's on the x-axis because nothing's gone up or down. So you find the x values at which we touch the x-axis, which in this case is negative 1 and positive 5. Now back to this g of x idea. G of x is equal to 2 times f of x. So for the input here is 3, plug in 3 for x, so now we have f of 3 inside our function. We need to pull out f of 3 and address that by itself. So we're going to go to f. F is the graph in this case. So we're going to go to the graph and find out, well, what is the output when the input is 3. And it looks like it's about 3. We're going to use 3 here just as an example. So 3 is going to replace that f of 3, and it becomes 2 times 3 equals 6. So that is how we use that funky notation. If you have a function within a function, be aware that sometimes you're going to have to pull it out and do it individually, then put it back in. So the piecewise function, first off, wherever the intervals are, meaning the x values that you're allowed to use, take those numbers and make dotted lines at those values, because that's going to separate the two sides of your graph. Then, if you have two functions, which we do here, create two tables. Now, as far as what goes in each table, that's dependent on the x values that are shown for each function. So the first function is less than or equal to 2. The second function is greater than 2. Now, before, what we were doing was leaving the 2 off if it wasn't equal to. I'm going to ask that you do it here. And what we're going to change is putting a closed dot for where I think we should use it, and an open dot where it should not be used. So you can see the 2 in the right-hand function open and closed on the left-hand function. Now, the table itself is going to come from the calculator with Desmos or with your calculator in class. So these are the y values I'm getting for the first function, negative 2x minus 1. So I take those, put them on the graph, as you can see. Take it all the way to the line, and here we are. Great. Closed dot here. So I have that reminder. That's why the closed and open dot is a good way to do this. So there's the left-hand side of my piecewise function. Now on the other side, we can still go to the calculator to get those values. And we're going to include 2 in our table just so we have a point that would exist on the dotted line. So here's our points. Now again, it's a good reminder that we have this open dot because we know where to plot it, but we don't fill it in. So these are my 2 sides of my piecewise function. Now down below, it's simply asking, where do you plug this thing in? So if it's f of 3, if it's f of 3, then plug in 3 where 3 is allowed. If it's f of negative 1, plug in negative 1 where it is allowed. Okay, so that is the review, guys. Hopefully you took the notes with me. On Tuesday, come in ready to roll.